سلام، وقت شما بخیر. به کلاس خوش اومدید. سلام علیکم. Hello everyone, welcome to our today's session. Thank you, Mr. Life. Good afternoon to you. Thank you very much. Okay, so I think we should wait for about 2 more minutes for our other students to come and join us. Then I will start the class and continue the last session's slides. If you're ready now, we can start the session. In the previous session, we talked about the structures of the software and talked about an example on the physiological structures of the human body, and that we know we have different structures in our body: bone structures, the vein structures, and the muscle structures. And for each one of these structures, we need different pictures to show them. So different specializations and different specialists need these pictures to reason about the human body. And the software systems are just like that. They have different structures, and we need views for each one of these structures to represent them. Before continuing the course, if you have any problem or any question about the previous session, please first ask your questions. If there is anything that needs more description, please let me know. Okay, so let's talk about views. Each view is a representation of a set of architectural elements for showing those elements and their relations among them. We will use views to document those elements in that structure. The view is written and also used by different stakeholders of the system. As we said before, a structure is a set of elements of the system itself. So the views are representations of structures. For example, we have module structures. The module structures are composed of a set of elements which are modules and the relation between them. And a module view is the representation of that structure. The view can enable us to document the structures, usually based on some templates, and these templates are based on a chosen notation. These notations usually are standardized or a de facto standard, so all the stakeholders and users of the system can read them, can use them. The architect designed the structures and document the structure using those views. So the architect will design the structure, and for showing the structure that he or she designed, he or she need to document them. The documentation is done using the views of the system. From this slide, we will talk about each one of the structures of the system. The first structure is the module structures. The first category of structures is the module structures. In the previous session, I think one of the students translated the class. Yes, Mr. Life. One of the students suggested to translate the slides. Okay. Module structures embody decisions on how the system is to be structured as a set of codes or code units or data units. So module structure is a static structure. It just show us the code units and data units that will build up the system. In any module structure, the elements are modules of some kind. We have different types of modules. We can have classes as modules, or layers as modules, or different divisions of functionalities of the system as a module, which are implemented in different implementation units. So the architect can decide on the granularity of the structure of the modules, on the size of the modules, if he or she decide a module to be a small unit of implementation or a big unit of implementation. Each one of the modules are responsible for some functionalities of the system. So they are assigned as areas of functional responsibilities. In module structure, we don't talk about the state of the system in the runtime or the state of the elements of the system in the runtime. In module structure, we just talk about the structure of the implementation as a static element. We have different structures, and there are other structures that manifest the software at runtime, but in module structure, we don't reason about the runtime, the state of the system at runtime. Using the module structure, we can answer these questions. For example, we can answer what is the primary functional responsibility assigned to each module, and what other software elements is a module allowed to use, what other software does it actually use or depend on. So having the module structure, we can reason about the implementation units of the system. Hello, Mr. Amar. Hello, Mr. Wali. Welcome to the class. At any point, if you have any question, please ask your question. Hello, Mr. Lice.
Thank you, doctor. How are you? I hope you're good. Actually, if you want me to clarify some slides, I have no problem for this.
Yes, thank you, because the last session I think you suggested to translate. So if it is okay for you, I will be glad
Okay,
if students think it's
no problem.
helpful.
Can I start?
Yes, please.
شلونكم اخوان ان شاء الله بكل خير. عندنا حاليا جاي تحكي على الموديل ستراكشر، يعني الهيكلية مالت التعليمات مالت البرنامج. كل برنامج قبل لا يتحول لأي كود، قبل لا يتحول لأي شيء تنفيذي داخل الرن تايم، لازم بيه شنو؟ بيه ستراكشر، تعليمات. يعني شلون لوجيك او شلون مثلا الجوريثم معينه، يعني هيكليه. يعني اكو عندنا مثلا مدخلات، تصير بعدين معالجه، بعدين تصير شنو؟ مخرجات. في حال اذا صار خطا العمليه تتكرر، اذا صار مثلا اذا اكو فيدباك. فهنا شنو عندنا؟ الموديل ستراكشر هو الهيكليه اللي راح تحول هاي كلها الى كود. يعني ذني كلها التعليمات اللي راح يتحولن الكود، سواء كانت تعليمات او سواء كانت داتا. تمام. فهاي ال الواجهة اللي احنا نشوف بها فكرة البرنامج شنو، يعني التعليمات الأساسية، يعني ماهية البرنامج تصير خلالها. يعني بدل ما أنت مثلا تقرأ الكود يعني ككود برمجي، تقدر تشوف الستراكشر مالته شنو هو، من متكون، بعدين تقدر توجه للكود، يعني نشوف شنو الفائدة من عنده. فاحنا جاي ننطلق فيو معين، تشوف فيو معين بالبداية له قبل لا تدخل بالكود نفسه بالتنفيذ، يعني حيز الران تايم. Thank you doctor, you can complete.
Thank you, Mr. Leith, for your translation. The next structure is the component and connector structure. This is a category of structures that reason about the system or runtime. So, in contrast to the module structure, which was focused on the static state of the system, the connector and the component and connector structures are focused on the state of the system in the runtime. These structures embody decisions as to how the system is to be structured as a set of elements that have runtime behavior. These elements are known as components, and the interaction between those elements are known as connectors. Different types of runtime components can be considered as an element. For example, we can have services as elements of the system. Peers, clients, servers, filters, or other type of runtime elements can be considered as the elements of CNC structures. Based on the chosen elements, the connectors are the communication vehicle among those components. For example, you can consider the call and return, or the process synchronization operators, or the pipes between different filters as the connectors of that special structure. The CNC views can help us answer questions like what are the major shared data stores if we have data stores, or what parts of the system are replicated, or how does the data progress throughout the system, or what parts of the system can run in parallel. So as you see here, the CNC structures are focused on the runtime state of the system. The CNC views are crucially important for asking questions about the system's runtime properties, for example, the performance, the security, and the availability. So based on using these structures, we can reason about some quality attributes of the system that are dependent on the runtime properties of the system. Please, Mr. Light, if you want to translate.
It's okay, thank you doctor. عندنا حاليا اثنين مصطلحات، الكومبوننت and الكونكتور ستراكشر. الفكرة من الموضوع كله، إذا عندك نظام معين، النظام مالتك أكيد يتكون من عناصر معينة. هاي العناصر سواء كانت كلاينت يعني يوزرية، بيرز يعني أطراف للنظام، فلترز، سيرفيسز، ذني كلهن عناصر. فأكو شيء بعد ثاني اسمه كونكتر. كونكتر هو حلقة الربط بيناتهم. فالفائدة الأولى من عنده إنه يربط هذني الأطراف، هذني العمليات يربطهن بالران تايم، يعني أثناء تشغيل النظام، أثناء تنفيذ العملية. تمام. الشغلة الثانية الإضافية بيه إنه هو يتصرف على إنه هو اللي يقدر يقيم النظام، يعني من خلاله أنا أقدر أشوف أداء النظام شنو، security مالته، availability مالته شنو. كل هذني مسؤول عليهن منو الكونكتور يعني حلقة ربط، يعني الكونكشن، اللينك اللي يصير ما بين هذني الأطراف. هذا كله يشتغل ايش وقت؟ يشتغل اثناء الران تايم، يعني اثناء التنفيذ، يعني مو مثلا يعني شلون simulation، لا، تنفيذ النظام فعليا هو اللي يقيس لك اياه بالريل تايم. فهسه اكو اسئله معينه يعني يجاوبنا عليها هو هذا مثل ما ذكرت الدكتوره، يعني مشاركه البيانات، سيستم ريبليكيت، ثروبوت كذلك، صار ما جاي اشوفها حاليا. سيستم كان تنفيذ النظام في حاله البارل، يعني بشكل متوازي. فاحنا هسه من الساعه حكينا عن شنو؟ حكينا عن بالبدايه انا اشوف التعليمات على شكل يعني فد هيكليه مو ككود. هسه بعدين راح يربط شنو؟ راح يربط هذين التعليمات بيناتهن سوا، يعني يسوي بيناتهن لينك، حلقه ربط بيناتهن. وهذني مو بس مجرد لينك الكونكتر، ما تنفذ كلينك، تتنفذ على انه شنو؟ هي تقيس اداء النظام وتفاصيل النظام كلهن اثناء الرن تايم. Thank you, doctor. You can continue, please.
Thank you, Mr. Lice. The last structure, the last category of structures that we will talk in this class is the allocation structure. The allocation structures show us the relationship between software elements and elements in other external environments. So in this structure, we have a mapping from software elements and some external elements from other environments that the software is created or is executed. For example, we can have the mapping between the software elements and the processors that those elements are executed on. So we have a mapping between software element and hardware elements, the hardware that those elements are executed on. Or we can have a mapping between software elements and the directories or files that those elements are stored in them. The files or directories that those elements are tested or developed or built in them. Another example is the mapping between software elements and development teams. Which software elements are developed by which teams? The assignment of software elements to the development teams. Mr. Lice, please.
Yes, doctor. هسه حاليا من بعد ما فهمنا بالبداية شلون آلية النظام شلون تصير، بعدين صار بيناتهم كونكشن. هسه الدور شنو؟ allocation، يعني توزيع. بس هالمرة ما راح يصير كسوفت وير، راح نتوزع.
Mr. Lice, excuse me. I think it's تخصيص not توزيع.
يعني مو أنا أحاول أبسطها. تمام، ممنون.
Thank you
خيري.
very much.
هسه النوب مثل ما قال الدكتور راح نخصص هذين التعليمات بناء على الهاردوير. يعني انا راح اخصصهن واخليهن يتجهن علما للهاردوير. يعني مثلا كل عنصر من هاي السوفت وير الاليمنت شنو علاقته بالبروسيسور، شلون راح تصير المعالجه مالته. تمام، يعني هسه انا راح اجمع سوفت وير وهاردوير كذلك بنفس الوقت. يعني اكو اسئله معينه كذلك يجاوبنا بها شلون انا اخصص كل معالج يعالج عنصر برمجي مثلا. البيانات شلون راح تتخزن، شلون راح تتخزن اثناء عمليه المعالجه واثناء عمليه التطوير. شنو تخصيص كل عنصر برمجي. تمام، فريق التطوير يعني مستقبلا انت اذا تتعدل على البرنامج وتطور عليه يكون لازم عندك اسس معينه انت تشتغل عليها، وبناء على هذا تتعدل. يعني ما تقدر تتعدل مثلا من الصفر، لا، اكو نقطه معينه تعدل عليها. اكو اساسيات، يعني كور مالت النظام، مثلا الكيرنل مالت النظام ما تقدر تعدل عليه لان هو اصلا النظام مبني عليه. يعني اذا غير بالكور مثلا غير بالنظام كله. لكن اكو اشياء معينه انا مخليها اساسا للتطوير، قابله للتطوير. تمام. فهذين كلهن أنا أخصصهن علما الفريق التطوير مستقبلا. Thank you Dr.
Thank you very much, Mr. Lai. The important point about structures is that structures can provide insight into the system. Structures can... Yes, Mr. Qasim. Hello, Mr. Qasim.
دكتور السلام عليكم.
Salaam alaikum.
عليكم السلام دكتور. Doctor, from the previous lecture and the recent slides, we understand that we have three structures, that is modular and connection and component and connector structure and the allocation structure. Three types, okay?
Yes, okay.
Every structure don't depend or has its alone state, don't depend of other. No relation between allocation structure and component and connector structure. Is that right?
They can cover some parts of the system along each other. So they may have some parts of the system in common. Okay.
Yes, Doctor.
They can have some disjoints along each other, but each one of them try to cover different perspective to the system.
Okay, Doctor. Every structure cover the subject, different from the other subject.
Yes, from a different view. They try to give us different views of the system. It's like, for example, consider that I have, for example, a toy. I have a toy. I want to describe the toy for another person. I take pictures from different aspects of the toy. Okay, so for example, I can take pictures from the backward or from the in front of the toy to cover all parts of the toy. Views and structures of the system are like that. Sometimes they can have some parts of the toy in common, okay? But their goal is to represent the toy from different aspects, from different views. Okay, Mr. Qasim? Mr. Qasim, you're welcome. So we have different we want to show a human body, okay? For showing a human body, we cannot use just one picture because we have different structures in a human body. So for showing different structures, we need different pictures. We need a picture to show us the structure of bones. We need a picture that shows us the structure of muscles or blood veins, I don't know. So we need different pictures because we have different structures. Or they have, or they show common parts of the system. Yes, they can show us. For example, I can see that here is the scalp, and the scalp is also can be seen in other pictures. But the goal of each structure and the view that show those structures are different. Okay? Thank you, Mr. Qasim, for your very good question. Thank you very much. Okay, Mr. Lai, I think, or I was talking about the insights, yes?
Yes.
Yes, okay. So different structures provide insight into the system because they try to show us the software architecture from different perspectives. They can help us to analyze the system. They can help us to have this power to analyze the system from different perspectives. So using all of those different perspectives, we can reason about the system on which quality attributes that system will have. The quality attributes of the system are very important, especially in the design phase, in designing the architecture, because after we design the architecture, some quality attributes will be provided using those structures, those architects, and some quality attributes cannot be provided. So the architecture is very important because it's the foundation of quality of the system. It's the foundation of which quality attributes our system will have at the end of the implementation. For example, the module structure, which show us what modules can use other modules, is strongly tied to the it can help us to reason about how the system can be extended or contracted. So if we have a module structure that is tightly connected to each other, it will be very hard to extend. But if we have a module structure that the different modules are independent from other modules, it's more easily it can be more easily extended. So if we look at the module structure of the system, we can reason about the extendability of that system. Or the concurrency structure. The concurrency structure is one of the structures of component and connector category. So the concurrency is one of the structures of the CNC category. We will talk about all these structures. Don't worry if you don't know them now. The concurrency structure can help us to reason about the parallelism within the system. If it is very important for us to execute different parts of the system in parallel, we can use the concurrency structure. We can reason about the deadlock or the bottlenecks of the system, the performance bottlenecks of the system. We can design an architecture for the system that is free from deadlock or performance bottlenecks. Another example is about the deployment structure. The deployment structure is one of the structures from the allocation category. Deployment is one of the structures from the allocation category. The deployment structure can help us to achieve the performance or high availability or high security goals of the system. So if we look at the deployment structure, we can reason about the performance. We can reason about the availability of the system. So using these structures, we can reason about the system. We can we can have insight into the system and reason about the quality attributes that the final software system will have. Please, Mr. Lice.
Thank you doctor. هسه حاليا اخوان عندنا structure provide in light. يعني معناها انه الستراكشر يعطيك بصيرة، مثل ما نقول بصيرة عن آلية البرنامج. فهاي البصيرة يعني شنو الفائدة من عندها؟ الهندسة التحليلية عندها قوة تقدر تفسر النظام بناء على الأساس اللي أنت تريده. يعني يحللون النظام بشكل تفصيلي، وحتى يقيسون التوافق مالته، الأداء مالته كذلك. فكلهن هذني كلهن موجودات وين؟ بالستراكشر. يعني أنت تقدر تشوف كل هاي التفاصيل تمام بالستراكشر. وكل ستراكشر إلى فد منظور خاص به. يعني كل واحد إلى منظور خاص به. يعني اكو ستراكشر إلى علاقة. هسه مثلا إذا أريد نجي للتفاصيل مالت الستراكشرات، مثلا the model structure شنو هذا؟ قلنا عليه قبل شوي، قلنا هذا يجسد التفاصيل مالت النظام. ستراكشرات شلون جاي يصير، شلون تستخدمها، شلون يصير ترابط بيناتهن. تمام. هما هسه اذا نجي اذا للكونكرنسي ستراكشر، concurrency structure يحكي عن غير منظور. المنظور مالته اللي هو شنو؟ توازي المهام. يعني داخل النظام شلون انا اقدر انفذ اكثر من مهمة بشكل متوازي، يعني parallel. تمام. شلون هذني يرتبطن. اما هسه اذا اريد نجي مثلا للديبلويمنت ستراكشر، هذا له علاقة علما بالاداء مالت النظام. يعني انا اذا اريد اشوف اداء النظام، فهنا تخصصي. انا اذا اريد اشوف مثلا شلون آلية اداء شلون تنفيذ المهام بشكل متوازي، اروح علما للكونكرنسي. اذا اريد افتهم هيكلية النظام كلها والتفاصيل مالتها، علما اروح للموديل ستراكشر. فكل واحد من هذين الستراكشر له فد هدف معين، وبناء على الهدف الفريق التحليلي مالت المهندسين يطورون عليه. يعني هو مو كله مثلا مو كله فد قطاع معين واحد ثابت حتى الواحد مثلا يقدر يدرسه. لا، التقسيمات تختلف. كل مجال إلى تفاصيل معينة، إلى أهداف معينة، وبالإمكان تطويره أو التعديل أو الإضافة، بس كل من على الاختصاص اللي أنا أهدف إليه. مثلا أنا إذا أريد أهدف مثلا لزيادة العمليات مالت النظام مالتي، لما نتجه للكونكرنسي. إذا أريد أشوف أداء النظام مالتي للديبلويمنت. إذا أريد أشوف كل تفاصيل النظام مالتي كلهن، يعني شلون جاي يصير العلاقة ما بين الفاريبلز مثلا، شلون جاي يصير ما بين الهيكليه اللي جاي يصير العلاقه الكونكتر قبل شوي اللي قلنا عليه. فكلهن وين ذني؟ بالموديل ستراكشر. ثانك يو دكتور.
Thank you very much, Mr. Lice. Okay, so it's very important to know about the structures of the system to reason about quality attributes. The quality attributes is an important part of our course. We will talk about the quality attributes in our future sessions. From this slide, we will talk about some structures from those three categories. Okay? For example, we have the decomposition structure from Modulus structures. Decomposition is one of the Modulus structures. The next slide, uses structure, is one of the Modulus structures. Uses structure. The next is layer structure. Layer structure is another Modulus structure. The next one is the class structure, which is also one of the module structures. So we will talk about all of these module structures. Then we will talk about some CNC structures, component and connector structures. And after that, we will talk about some allocation structures like the deployment structure, the implementation structure. So in the next slides, we will talk about some of the structures from those three categories. Okay, Mr. Lice, please translate this and tell other students that we will go through different structures from our three categories of structures.
It's okay. اخوان حاليا احنا راح ناخذ اكثر من ستراكشر اللي هن يصيرن ضمن حقل الموديل ستراكشر. اول واحد هو decomposition structure اللي هو الهيكل التحليلي، يعني اذا كانت ترجمتي صحيحة. بعدها راح نتجه علما لليوزر ستراكشر، لليوز ستراكشر اللي هو هيكل الاستخدام. من بعدها نتجه علما لللاير ستراكشر اللي هو يعني شلون اترجمها ما اعرف ليه، يعني هيكل الطبقات، او يعني اذا كانت ترجمه حرفيه فهذين كلهن راح يصيرن كلهن ضمن الموديل ستراكشر، يعني كلهن افرع له، راح نجيهن بالتتابع، وعلى هذا الاساس راح يصير الشرح مالتهن لان هن متسلسلات حسب ما فهمت من الدكتوره. Thank you doctor, you can continue please.
Thank you very much. Before talking about the decomposition structure, I want you to have a quick break. I showed other class picture. I want to show you that picture, so we can have a quick break. I can go to the that class and copy the picture from that class. Okay, so until then, we can have a 10 minutes break, so I can copy the picture and show you that picture too.
Thank you. اخوان 10 دقائق استراحة.